Okay, let's have a look at the nitrogen cycle. Like we did for the carbon cycle on another video, let's start up in the atmosphere. So what we have is atmospheric nitrogen. We have nitrogen up in the atmosphere. You probably know that the air you're breathing is about 78% nitrogen. Okay, so in the atmosphere we've got 78% nitrogen, 21% oxygen, and 1% other stuff. Other stuff being argon gas, CO2, water vapor, etc., etc. So we've got nitrogen in the atmosphere. How did it get there? Well, one way it got there is from volcanoes that we can see over here on the top left. So we've got oxides of nitrogen venting from inside the Earth. So from volcanoes. Let's just call them volks. Right, you get what I mean, volcanoes. Okay, so we've got nitrogen coming out of volcanoes. Volcanoes give out lots of things. They give out water vapor, carbon dioxide, magma, and then we change its name, call it lava. But they also give out oxides of nitrogen. So that can put nitrogen into the air. Now, how do we get it out of the air? Right, let's follow the next arrow coming down, down to my funky little plant. I know it doesn't really look like a plant, but trust me, it's a plant. Now, the plant can't actually use the nitrogen from the air. Neither can we. Animals can't, plants can't. But what? Oh, that's not how you spell nitrogen. And there we go. So what we have here is nitrogen-fixing bacteria. It's because there are some bacteria who actually can use the nitrogen from the air. Plants and animals can't. Certain bacteria can. So we've got this nitrogen-fixing bacteria. Now, the type of plants that these tend to hang around in is legumes or leguminous plants. Now, they're actually in the root nodules. I'm not sure if you can tell from a little diagram. I've tried to draw little black dots on the roots. So these nitrogen-fixing bacteria are in root. They form in root nodules of legumes or leguminous plants. Now, what the heck is a legume? Well, it's things like peas, beans, clover, etc. So peas, just jot these down here, beans, clover. There we go. So we've got this nitrogen-fixing bacteria. They can fix it, and they fix it into soil nitrate. Now, nitrate, of course, being NO3 minus. This is the usable form, right? So nitrate is NO3 with a minus there. That's the usable form of the nitrogen, is the soil nitrate. Now, bottom arrow here, another way we can do that is use fertilizer, right? So we're talking chemical industry here, because we can go to the shop, buy some fertilizer, and throw that onto our garden. So let's call it chemical industry. And what we're really talking here is fertilizer. Yeah? So we've got soil nitrate in the ground. Great. Now that plants can use. So this up arrow here, this is the soil nitrate, gets taken up by plants. So that's how plants get their nitrate. They can't grab the nitrogen from the air, neither can we, but they can get it by taking up the soil nitrate. Great. Now, what happens is that animals get their nitrogen by eating the plants. Okay, so the plants take it up through the roots, animal comes along, eats the plant. Great, we've now got it in plants and animals. Now this is in terms of things like protein, etc. Right, so we've got nitrogen in the proteins of the plants and animals. Nitrogen is a very important element for making biomolecules like proteins. Okay, grand. Now, the plant, unfortunately, just to the left of that lovely, healthily looking tree, there's a bit of a black, deadish looking tree lying down. Yeah, the plant's going to die. So it's going to die and decay. So decay of organic matter can put nitrogen back into the atmosphere. Decay of organic matter can also put nitrogen back into the soil. Okay, so just to the right of the happy little cow, actually happy little cow going to the toilet, we have a dead cow. So dead organisms. Now, not just the dead organisms, but also the waste. So the cow's going plop, 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 the one on the left. So it's feces. So dead organisms and feces put nitrogen back into the soil again. Okay. Now, this is not a soil nitrate, but we have nitrate bacteria. To turn it back into the nitrate, actually, first we have nitrite bacteria. Now, nitrate is NO3 minus. Nitrite, if you take off an oxygen but leave the charge there, so we're left with NO2 minus, we change the 8 to an ite. So first we have nitrite bacteria. They work on it a little bit, and then we have nitrate bacteria. They work on it a bit more, and then we've got our soil nitrate back. Cool. A couple more arrows. Alrighty. Let's go over to the next arrow, I guess. Another way that nitrogen can be put into the soil is soil nitrate. Well, storms are a thing. Lightning can actually fix nitrogen. So by fix nitrogen, we mean hook it up with some oxygen. We're really after making our nitrate. So nitrogen fixation or nitrogen fixing, nitrogen fixing, that can happen from lightning. That supplies enough energy to fix the nitrate to make it react with oxygen, and the nitrogen react with oxygen and give us some nitrate. So cool. Now we can go back up into the atmosphere. We started by going up to the atmosphere with oxides of nitrogen venting from volcanoes. Well, let's finish with going back up into the atmosphere. Now this is coming from sort of a swampy area. We've got another type of bacteria, but instead of the nitrogen fixing bacteria, we've got D, because we're taking it away. We've actually got some denitrifying bacteria. Hang on. Let's write this down. Denitrifying bacteria. Now, these guys tend to be found in waterlogged soil, which is why I drew a little swampy area, because they're in the waterlogged soil. There we go. And that is essentially a quick rundown of the nitrogen cycle. I had to do it kind of fast because it's recess time and I'm nearly on class. So there we go. There we have the nitrogen cycle to complement our carbon cycle that the previous video. Now we've got a cycle for carbon and a cycle for nitrogen.